Hello class, today is going to be 31-3 and we're going to take a look at some right triangle trigonometry. We're going to be examining SOHCAHTOA and using that. So we're going to state the 6 basic trigonometric ratios and we're going to find a missing side using sine, cosine, and tangent ratios. So as a quick review, remember that we are able to, with a right triangle, we are able to name the sides from a given angle. And so from this given angle here, theta, we would say that this is the opposite side to that angle. This is the adjacent side to that angle, and then my hypotenuse is always opposite that 90 degrees. And then we said that we can compare two sides to one another. So I can say I can compare like opposite to the hypotenuse, the adjacent to the hypotenuse, opposite to the adjacent, and we all got these corresponding ratios. Now these had names. We said the ratio that's opposite to the hypotenuse was a sine ratio. The adjacent to the hypotenuse was a cosine ratio. The opposite to the adjacent was the tangent ratio of theta. And so on and so forth. And we said that these last three were the reciprocal of the first three. And then we said to abbreviate it, instead of saying sine of theta, we would say sine of theta. We could abbreviate it this way. Instead of saying cosine of theta and writing it out that way, we would abbreviate it as cosine of theta. And we said we need to memorize them. And one of the ways to memorize the sine, cosine, and tangent ratios is by using SOHCAHTOA. And that helped us memorize it. And then to memorize the reciprocals, we said S goes to C, so S goes to C, and C goes to S, and then tangent and cotangent go to each other. And then the last was it's never just sine or cosine or tangent. It's always sine of an angle, sine of an angle, sine of an angle. There must be an angle present. So first couple of these, let's take a look. It says find x. So I need to establish a relationship. I know SOHCAHTOA. And so with the information, I have to find this missing side. So I do have my adjacent, and I have my hypotenuse. And so to be able to find that, which has adjacent and hypotenuse, was going to be cosine. So I'm going to say the cosine of 31 degrees equals adjacent over hypotenuse. Then, algebraically, I want to get that variable by itself. Establish an equation. Now I want to get x by itself. So I multiply both sides by x, and so I get x cosine of 31 degrees equals 20. Divide both sides by cosine of 31 degrees. And so I get x equals 20 over cosine of 31 degrees. Now this I would enter into my calculator. Now remember, because this is in degrees, I need to make sure that my mode is going to be in degrees. So 20 divided by the cosine of 31 degrees, you're going to get approximately 23.33. And that's going to be my answer. So the first thing that I did here is I had to set up a relationship, and that's what I did here. I said the cosine of 31 degrees equals adjacent over hypotenuse. Then from there, I got x by itself, which is what I did for the rest of this, and once x by itself, I was able to enter that in my calculator, and I got my values. So the next one, find x and y. I'm just going to say let's just find x here. So to find x and y, what we're going to do, or just find x, it's opposite, but I also have my adjacent and I have my hypotenuse here. I'll just use why not? So my sine of 42 degrees equals opposite over hypotenuse. Now step 2, solve for the missing variable. I want to get x by itself, so I multiply both sides by 13. And so 13 sine of 42 degrees is going to give me x. So I entered that into my calculator, and I'm going to get approximately 8.7. That's going to be my answer. Next one, I have find x, and so here's x here. I want to find that value. So from that 17 degrees, I have my adjacent and hypotenuse. So that's going to be cosine again. So I'm going to say the cosine of 17 degrees equals adjacent over hypotenuse. Now solving for x, I'm going to multiply both sides by x. So I get x cosine of 17 degrees equals 44. Divide both sides by cosine of 17 degrees. And so I'm going to get x equals 44 over cosine of 17 degrees. So I want to enter that into my calculator. So 44 divided by the cosine of 17 degrees. And I get approximately 46.01. And that's going to be my answer. Let's do one more. So this one, from this given angle, I have opposite and hypotenuse. So to do that, to set up my relationship, it's going to be sine. So I'm going to say the sine of 70 degrees equals opposite over hypotenuse. So I have to get x by itself, multiply both sides by x, divide both sides by the sine of 70 degrees. And so I'm going to get x equals 6 over sine of 70 degrees. So entering that into my calculator, 6 divided by the sine of 70 degrees, that's going to give me approximately 6.39, and that's going to be my answer. So we can also find values for like sine, cosine, tangent just using our calculator. So it says find each of the following using your calculator, and so I'm literally just going to enter the sine of 55 degrees in my calculator, and I'm going to get 0.82. If I enter the tangent of 45 degrees in my calculator, I'm going to get 1. If I enter the cosine of 60 degrees in my calculator, I'm going to get 0.5. Now cosecant of 30 degrees. So to enter this, we know that this is, I have to relate this to sine. So I'm going to have to relate that value to sine. So to do that, what I want to do is I'm going to convert that into sine. And so we said that this is the same as 1 over sine of 30 degrees. And so entering that into my calculator, this is going to be 1 over, and then you're going to get 0.5, which is going to give me 2. Now the last thing here, and I'm just going to do the first one, it says find the 6 trig ratios from each of the following. So from this angle B, so this is angle B right here, it's giving me my ratio, which is opposite over the hypotenuse. So I need to label that. So this is going to be my opposite 1, and this is going to be my hypotenuse 2. And then from there, I could use the Pythagorean theorem, a squared plus b squared equals c squared. So 1 squared plus b squared equals 2 squared. Now if I did that, I'm going to get root 3 for b. Now that I have that, I can go through and I can label all 6 trig ratios from that angle, from angle B. So I can say the sine of b, opposite over hypotenuse. Cosine of b, adjacent over hypotenuse. Tangent of b, opposite over adjacent. And then I can rationalize that, so that'll be root 3 over root 3. So now my reciprocals, the cosecant of b, that's just going to be 2 because I flip it, right? I have to flip those. My cosine of b, that's going to be 2 and then root 3 over 3 because I have to rationalize that. And then for the cotangent of b, that's just going to give me root 3. And so all 6 of these here are going to be the trig ratios from that given angle B. So this concludes our lesson. If you guys have any other questions, please leave them in the comments.